Hello, Mr. Barlow, and anyone else who might happen to just be watching this video elsewhere. Uh, I was thinking about all the cool stuff we've done this year in computer science, and I was trying to think of what the best thing to do a quick little tutorial would be, and I think the coolest thing I learned that I could quickly share is pointers. They were super helpful in my project, so I'm going to do a quick little tutorial on references and pointers. I'm going to do a quick little spiel first on references and then a quick little spiel on pointers, and I'll finally finish off by showing how I implemented these into my code. Alright, so I'm going to first start by going over references. I didn't use these as much in my project, but they're still helpful, so I'll go over them really quickly right before I do pointers. So here's a quick little program that I made that kind of shows a very simple use for references. So I'll start in the main. So I have this int a, which equals 5, and then I have this reference called AR, and I set it equal to A. So basically what that does is AR is always going to be equal to A from this point forward. So if I see out A, it'll give me 5. If I see out AR, it'll give me 5. And then since it equals 5, if we added 10 to it, it would equal 15. So that's what I did here, is like I took A and I added 10 to it. But then I also added 5 to AR. So you might expect for me, if I just see outed A, for it to see out 15, because it equals 5 and I added 10. And then I also added 5 to AR. So you might think that at this point A equals 15 because I just added 10, and AR equals maybe either 10 or it might also equal 20. But you wouldn't think that A would equal 20. But in this case, because we added 10 to A and 5 to AR, they both add to each other. So if I see out A, it'll give me 20. If I see out at AR, it'll give me 20. It doesn't matter if these both said A right here, if they both said AR, they both just add to the same total because they're basically in the same spot in memory. So I also created a quick little function that can also kind of show this real fast. So I called it ref test, and it takes in a reference. So in this case A, so this int reference passref will be a reference to A in which I put in. So when I put it in, it equaled 20, as we see here. And then I add 10 to that reference, passref. But since passref also equals A, just like AR equaled A will then equal 30 because we added 10 to the reference, which in turn adds 10 to the actual value of A. So that's just a quick little show. So I can do a few other things if I exit out of here and actually go over to the code. So if I change this and I remove this little ampersand, then it won't work at all because well, it will work, but it won't work the same way. It won't add 10 to A because basically it's just taking in A and saying passref equals A, and they'll add 10 to it. So passref will equal 30, but A will still equal 20, as you see here. So instead of being 5, 5, 20, 30, it's 5, 5, 20, 20, because that 10 never gets added to the A. It only gets added to the thing. So these references are helpful because they save a lot of memory. Like, you're not passing the value every single time, and it can also be really helpful with arrays. Okay, so now I'm going to go over pointers. So I'm going to start with this quick little code right here. So we start with int a equals 6, and then if we were to run, and then we're going to see out A, and then we're also going to see out ampersand A, or the reference to the location in memory of A. So if I run this, it's going to print two different things. It prints 6, which is the value of A, but it also prints out this right here, 00C5, blah, 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 whatever, which is basically the location in memory for this specific variable. So this is where the program looks for the number 6 in the data. So then we can do a little bit with that. So if I put in some other code that I wrote a little earlier. So then we have this new thing which is called a pointer, which is int. Oh god, I actually don't know what this is called, but this little character AP, and we're going to set that equal to ampersand a, which we had just printed here, which equals this right here. So it's the location in memory. So if we set the pointer AP to be equal to that, then this pointer equals that position in memory. So then we can see out AP, and it would just give us the same thing we got here. But then we can also print out that AP. Again, I don't know what that character is called, but it's basically dereferencing the pointer. So then that will actually give us it will give us the, so this is the position in memory of, so this is equal to this, which is the position in memory of this, and this will give us the value of what it finds at the position in memory. So if I run this real fast, it gives us 6, then the 2 identical pieces of memory, because we set this pointer to be equal to the point in memory of A, and then all the way back, and then that AP equals 6. So I made a little notepad document. So if we look at this, A is a value and equals 6. This is the memory address, so it's going to be something like that. And AP in our code is a pointer to a memory address, which will also equal the same thing as this above. And this will be what it finds at that position in memory. And in this case, it would also equal 6. Okay, so lastly, I'm going to show how I used pointers in our project this year. So it all kind of centers around this texture declare thing which I used, which I'm not going to completely explain exactly how it works, but basically it's a class that contains a bunch of textures, and I can just use this class in many different types of, in all of my different files universally, so I don't have to worry about declaring a giant block of like 30 or 40 lines of code in each single one. It's just, I can simply just declare, as I do here, texture declare text deck, and then I could, for example, say text deck dot blue left or whatever, and then I'd get the blue left arm texture. But because this class contains, a bunch of, it's like an array of textures, so it contains a lot of data there, and also it contains a bunch of texture files that I've loaded into the class. I obviously don't really want to duplicate this every single time I create a projectile or every single time I create a tank. But if I just create it once in my main code, which is the only time I declare it, right here, at the very start of the int main, I declare my class texture declare text deck, then I can just use pointers so that I can find this point in memory where it contains this texture declare class, instead of having to duplicate it over and over again every time I create a projectile or a tank. So I'll quickly go over how I go about doing that. So it starts when I create one of my tanks. So I also have a class called tank, and every time I create a tank I want it to contain all the textures, but I don't want to send it directly, so I pass it by pointer. So what I do is I have my texture declare here called TextDeck, but if I send ampersand TextDeck, as I said in the previous little section, that sends the address of memory, or like the address in memory for this texture declare right here. So then when I go to my tank, I'm able to, right here in the constructor, it takes in that texture declare. So that's where I'm passing it right here, at texture declare. That goes straight to the constructor. And in the constructor I've created this pointer right here called texture declare TextDeck, which is almost identical to this one, except it's a pointer. So instead of having all of the data like this one does, it just has the address in memory, and I can use commands to retrieve all that data but I don't actually have to pass it. I just need to know where in memory it is. So I save a ton of, so I don't have to use memory, where I don't need to be using. So it comes into the constructor here as texture declare TextDeck ref, and I set that to TextDeck. So now I have this pointer right here, which contains the point in memory for TextDeck, not the actual texture declare class. And then later, when I need to set my texture, I can say TextDeck and then point. It's a little different if it was like an actual texture, or if it was an actual class and not just the pointer. I would say like TextDeck dot textures, because this is like an attribute in it. But for a pointer I would say slash and then the little arrow key. So then I can say body sprite dot set texture TextDeck textures. So I've just taken one of the textures out of that class from my texture declare file. But instead of, every time I create a tank here saying duplicating my class, I just find this one that I have in the main, and I use that. That way I can save a ton of memory and not be super wasteful, and it speeds up my code a lot. Like, it wasn't working at all because it would take so long to duplicate, and we haven't really reached a huge scale yet using this code, but if we were to increase the scale where we had a bunch of tanks or a bunch of projectiles, duplicating it just simply would not be a viable option. But by using pass by pointer, we're able to use very little memory. Like it only uses enough to use that small 6-digit code or whatever that represents its address in memory. And we use the same thing in projectile. Every time we create a new projectile, we ask for a address in memory towards a texture declare, so that we're able to use the textures but not have to actually have a copy of the class.